In 3.1b, C, and D, we're going to learn how to make a scatter plot to display the relationship between two quantitative variables. We're going to describe the direction, form, and strength of that overall pattern of the scatter plot, and then we're going to recognize any outliers in that scatter plot. So let's first start by defining what is a scatter plot. The key thing here is that it shows the relationship between two quantitative variables. Scatter plots can only be created for things in which we could have ordered pairs with numerical values. Things with word answers such as eye color would not work for a scatter plot. Second point, what you're going to do is put the values of one variable appear on the horizontal axis and the values of the other variable will appear on the vertical axis. Most of the times, remember, the explanatory is the x, so we tend to put the explanatory variable on the horizontal and then the response variable on the vertical. We will learn later in the chapter that putting the explanatory in the response versus the response in the explanatory as an ordered pair won't actually make a difference in our analysis. The third point is that each individual in the data appears as a point in the graph. If you recall the previous video, what we looked at is we started off looking at the Chapter 1 and Chapter 2 test results where every point on the scatter plot was a particular student. Now, to make a scatter plot, it's not difficult. First thing we're going to do is to decide which variable goes on each axis. Again, it doesn't matter if you do explanatory and then response or response and then explanatory. Just be careful though, whichever one you decide, label and scale the axis. You must label the x and y axis. The last step is then going to be to plot the individual data values. You may be asked the type of association that the data has after you see the scatter plot. If it's a positive association, what you're going to see is the explanatory and the response variables move in the same direction. Again, if we have a scatter plot, you're going to see a relationship that they're both moving positive or upward at the same time. A negative association, the explanatory and response are going to move in opposite directions. In that case, as maybe the x's get larger over here, if the x's are small, the y's might be high. As the x's get larger, the y's are going to actually get smaller, so you're going to see a negative slope. Now, outliers, definition of that is a point that deviates from the overall pattern. In any of our data sets up here, an outlier in this case might be one over on this side. An outlier on the bottom might be over here. It's one that looks clear-cut that it's not in the pattern. Now, unlike previous chapters with univariate data, there is an outlier test. With bivariate data, which means x and y are two different sets of data, there is no particular test for an outlier. It's just more of a visual connection that you see. Now, if you're asked to describe the overall pattern when you have bivariate data or ordered pairs, there's an acronym we use. It's called DOFS to help us remember. Remember when we had univariate data or one set of data, we did the SOX, shape, center, and spread. We had an acronym. In this case, we'll talk a little bit more about what DOFS means. Technically, it's an English term where if a gentleman's wearing a hat and they tip their hat to a lady, that's called you doff your hat. Now, ultimately, in this chapter, we're going to write equations such as this. It might look like an equation of a line where this little symbol here is called a predictor, or it's called a hat. You need to put a hat over your response variable. So don't forget your hat and don't forget your DOFs. What does DOF stand for? It stands for direction and form. And then the last one is the strength of the relationship. So after you make a scatter plot, you're going to say if it's a positive or negative direction. Is the form linear, curved, quadratic? And is the strength, would you say strong, somewhat strong, weak, or no relationship whatsoever? Also, don't forget the O. Do you see any departures from the norm, or do you see any obvious outliers? If you do, you want to talk about those. Now, similar to Chapter 1, when they said describe the SOX or the univariate data, they're not going to tell you these key components. In bivariate data or scatter plots, they're just going to say describe the pattern, and again, it means you must talk about DOFs. Looking at this first example of height and weight of students, here are various ordered pairs of the heights in inches and the weight in pounds of students. The question is there a relationship between the height of students and their weight? How can you tell? Can we predict weight from height or vice versa? A scatter plot is the only choice for displaying this relationship because it's two quantitative variables. Again, that's called bivariate. What I did here is I created a scatter plot, and I'm going to actually label my axes here. So this is our height. Don't forget to do that in inches. And then this is the weight in pounds. And I'll show you in a little bit how to actually make a scatter plot on the calculator. But just remember what we would typically do for graphing this. We would do our tick marks on here and label them appropriately. And then come on in and just find the ordered pairs 76 and 200. So find 76 and 200, and you plot that particular ordered pair. And we do this. Now, describe the relationship. Let's go through the dots of it. The direction. In terms of the direction on here, it's clearly a positive direction. So what I would say for DOFs is there's a positive association between height and weight, and that the taller the student tends to weigh more. You want to put this in context, and the context means if you just said there's a positive association, the AP board is going to say about what? Give me some context about it. That means with respect to the height and weight, so give this detailed information. Now I'm going to go to form next. The form on here, if you notice, is I would say it does look somewhat linear. There's a little bit of a straightness here, and then it starts to curve a little bit. And it's okay to kind of be wishy-washy. So for the form, I just said it's slightly linear with some clusters around heights of 65 to 69. So we see some clustering around in here. And where the weights are at 160 to 175. So I'm kind of talking about where I see that clustering happen. Now the strength, I would say this is a somewhat strong linear relationship. So with that, moderately strong, in that students with similar heights have similar weights. We see kind of the proportion happening. Lastly, are there any obvious outliers? Maybe we would say that this fellow right here is an outlier. So with that, we could say that there could be one possible outlier, and that's the student at 76 and 200 pounds. Not necessarily sure, so if you didn't say one in this pattern, you would probably be okay. Again, it's possibly an outlier. Now I want to show you how to actually make this scatter plot right here, so please do practice this right now. The screenshots down here are actually for a different set of data, but let me show you the key steps that you're going to use. What we need to do is enter this data into the graphing calculator. We're going to be using the Stat button. So we want to hit Stat and go to Edit until we get to the lists. Now I'm going to use List 1 and List 2. So based on my data, let me just label it correctly so I do this right. Remember when you type this in, make sure they still look like ordered pairs and they correspond with each other, and get it in the list. Now to trigger the graphing, we're going to reference the stat plot we did for box plots and histograms. So to do that, remember we do second y equals or second stat plot, and you get this screen. So click into that. When you get into here, select on and hit enter. Now the scatter plot is the very first selection, so choose that. When you do it, you're going to see it says the X and the Y. You're going to go into here and put which lists you're in. So remember, don't type L and then 1. Actually find L1 on the calculator, which is above number 1. So put L1 and I put L2. Choose your marking and your color. When you're ready to graph, I recommend going to the Zoom button. When you click Zoom, you're going to choose number 9, which is Zoom Statistics, and it'll actually get you a great window. And that's how you can get the scatter plot. When you would do that on paper, then trace it over, and then don't forget to label your X and Y axes. Let's do another one, a track and field day. The table below here has 13 students in a stats class. Each member of a class ran the 40-yard sprint, and they did the long jump. And they have all of the ordered pairs labeled vertically this way. Is there a relationship between sprint times and long jump distances? So let's make the scatter plot. On here, I'm choosing to put sprint time on the explanatory, long jump on the response. It could be vice versa on that. It doesn't necessarily matter, but make sure to label the axes. Plotting the ordered pairs, let's go to 5.41 in 171. So it's probably this individual here. Plot all of your data. And then they're going to ask us to go through and explain the relationship. Now notice the state, plan, do, and conclude is kind of coming into play. The state for this one is there a relationship between sprint time and long jump distance? Easily said. What's our plan? Well, we make the scatter plot. Let's do the actual analysis of our DOFs, and that will end up making our conclusion. So on the next slide, I'm going to write down what the DOFs are, but let's just briefly look at it with the graph in front of us. In terms of the direction, we could see that there is a negative relationship, it's going downhill, between sprint time and long jump, meaning as the sprint time gets really slower, or that it takes them longer to do it, their long jump performance is not as good. The form on here, I would say, is somewhat of a linear pattern. The strength is not that strong because the points don't closely form a linear pattern. I mean, it kind of is actually. The strength, I would say, is moderately strong, but I'm not really sure because it starts to deviate in here. And then outlier, there possibly could be an outlier with this particular individual. So let's highlight those responses. Again, the direction, there's a negative association between the two variables, so state that in context. That's what I meant for my ... The form is somewhat of a linear pattern on that. The strength on here, not strong. The points don't closely form a linear pattern. Maybe moderately strong is decent, but definitely I would say don't say it's a strong pattern necessarily. And in terms of outliers, there could be one possible outlier that we talked about, that individual who's at 8.09 seconds and then 151 for their long jump. What can we conclude then? We can conclude that sprint time may be an indicator to some degree in the long jump with a linear form. I will tell you on AP exam, for this type of problem, you don't technically have to be as formal as state, plan, do, and conclude. But what you definitely need to do is, if the data is not plotted out for you, you must plot your data. So make the scatter plot first, talk about your DOFs, and then make a conclusion. Let's look at another example here. Here's some factual data about McDonald's hamburgers. We have 9 different types of burgers. We have the carbs in terms of grams and the fat. They basically want us to describe what we see. So is there a relationship between the amount of carbs and the amount of fat in McDonald's hamburgers? Well, let's make a plan and make a scatter plot. Right here is my scatter plot, and I'm choosing to put the carbs on the x-axis and the fat on the y. It's just how I chose to do it, and I plotted the ordered pairs. Let's describe the DOFs for it. So in terms of the direction, I would say there is definitely a positive association between carbs and fat grams in McDonald's hamburgers. In terms of outliers, do we see any obvious outliers? I would say not really. Possibly we have here the Big Mac that might be an outlier. Form and strength, I'm just going to do it one time together. I'm going to say for this that the form is a fairly strong linear pattern. With that, I can make a conclusion, and my conclusion is going to be that as the amount of carbs increases, the amount of fat increases linearly with the McDonald's hamburgers. Let's wrap up our notes with one last example, this time about McDonald's salads. Let's take a look here at the amount of sodium and fat in McDonald's salads and see if there's a relationship. Again, we pretty much did our state. Our plan is to make the scatter plot. Here's a particular scatter plot right here already made. Let's do the description of the DOFs on here. Now, in terms of the direction, this time I would say there's a positive association, but not to the same degree that we saw with the hamburgers. In terms of, I'm going to go to form next. The form on here, there's not a clear linear form with here. I'm not sure if I should draw the line here or if I should go here. It's much more spread out and not really even much of a pattern. The strength, there's a weak relationship among all the salads, really. And in terms of the outliers, there's really no outliers, but there are clusters. You could say there's a clusters of salads kind of in between this range, and then you have another clusters here. So on an actual free response question, I would say that their rubric would require you to talk about these clusters. If not, you would probably go from a 4 to a 3 within that. So ultimately, our conclusion, I think we could say that there's really not a linear relationship of much sorts between the sodium and fat content in the McDonald's salads.